We have all been there. You have a measurement in one unit, like kilometers per hour, and you need it in meters per second. But the moment you go to calculate it, you freeze. Do you multiply by 3,600 and divide by 1,000, or is it the other way around? Guessing leads directly to mistakes. Instead, you can use a three-step system that relies entirely on fractions to safely convert any unit into another. By the end of this video, you will confidently convert 60 miles per hour into meters per second using one continuous line of math. To pull this off, you have to get out of your head and onto a piece of paper. You also have to commit to writing down the words, like miles and hours, along with every number. By forcing the calculation onto the page and dragging the text along with the digits, you turn a precarious mental guessing game into a rigorous visual system that verifies its own accuracy. Step 1 starts with a conversion we already know. Let's look at a baseline example, converting 3 kilometers into meters. Because 1,000 meters equals 1 kilometer, this fraction mathematically equals 1. In step 2, we multiply our original 3 kilometers by this fraction. This changes the unit label without altering the actual distance. We keep all alphabetical labels strictly attached during this step. At this point, the equation looks unnervingly messy. You have words grouped together on the top and the bottom, and it doesn't look like a clean answer. Step 3 fixes the mess. Whenever the same word appears on both the top and bottom of the fraction, cross them out. We strike through km on top and bottom, leaving only m. Now calculate the remaining numbers. 3 times 1,000 equals exactly 3,000 meters. Treating alphabetical unit labels as actual mathematical variables allows the equation to solve itself by visually confirming what belongs and what needs to be removed. To see how this system protects you, let's look at what happens when you make the most common mistake, accidentally flipping the conversion fraction upside down. This diagram shows the incorrect setup. We are trying to multiply 3 kilometers by 1 kilometer over 1,000 meters. When we multiply this across, the terms merge to create an output of 3 kilometers times kilometers, all divided by 1,000 meters. Look at the words. There are kilometers on top, but only meters on the bottom. Because there are no matching words on opposing sides, you are physically blocked from crossing anything out. This is your immediate red flag. Whenever a cancellation is strictly impossible, you know the setup is backwards. The fix is instant. Just flip the fraction over and recalculate. The inability to cross out words acts as a hardwired alarm system, exposing structural errors before you even reach the final calculation. Now we escalate to a dual unit scenario. We are going to convert kilometers per hour into meters per second. Multiply 1 kilometer per hour by 1,000 meters over 1 kilometer. The km units cancel. Then place our time fraction, 1 hour over 3,600 seconds, upside down, putting hour on top. The h units cancel. The remaining 1,000 divided by 3,600 gives 0.277 meters per second. By isolating the variables and attacking them one dimension at a time, you prevent cognitive overload when faced with compound measurements. We are ready to fulfill the challenge from the beginning of the video, converting 60 miles per hour into meters per second in a single continuous equation. This continuous setup shows the first half of the chain. We take our base speed of 60 miles per hour and multiply it by our distance conversion, 1,609 meters per 1 mile. Without stopping, we attach the time conversion directly to the exact same line of math, 1 hour over 3,600 seconds. Now we follow the cascade. Mile crosses out on the top and bottom. Hour crosses out on the bottom and top. The only letters remaining across the entire string are meters over seconds. With the right units confirmed, we execute the final arithmetic. We multiply all the top numbers together to get 96,540 and divide that by the 3,600 on the bottom, resulting in our final solution, 26.82 meters per second. This cascading logic provides a consistent method for handling complex conversions, replacing the need for memorized formulas with a self-verifying process. The rules are strict but simple. Write your conversion as a fraction equal to 1, retain all alphabetical labels, and cancel identical opposites. Try this right now. Grab a piece of paper and use this specific visual method to calculate the seconds in a calendar year. This framework transfers perfectly to chemistry, physics, and daily life. Shifting your approach from rote memorization to a reliable methodology means you will always know exactly how to find the answer.